Hello students, welcome to the maths class. Today in this video I am going to take the revision of exercise 2b. In this exercise you are going to study composition of functions. This composition of functions I explained in my previous videos, but today I am going to take some questions of exercise 2b in which this composition of functions will be there. So in short, once again I will tell you what is the composition of functions. Then after that, as a revision, some questions of exercise I will explain. Some question of exercise 2b I will explain. So you see what is the composition of functions. Suppose you are having two functions f and g such that a to b is a function, a to b is a function, and one more time you see f such that a to b and g such that b to c. These are the two functions, f from a to b, g from b to c. Then composition of f and g will be GOF such that a to c. So this is the composition of functions f and g. Now here in this case, domain of GOF is equal to domain of f. You can see domain of f is a, domain of GOF is a. So domain of GOF is domain of function f. In the same way, codomain, here I am writing codomain of GOF is equal to codomain of G. You can see codomain of GOF is C and codomain of G is also C. So you have to keep in the mind, if f and g two functions are given, f is from a to b, g is from b to a, then their composition GOF will be from a to c. So domain of GOF will be domain of first function f, and domain of codomain of GOF will be codomain of second function g. One more important thing I am going to tell you. You see here, just before I told you, suppose you are having f such that a to b first function and g such that b to c second function. I told you about GOF is a to c. I told the domain of GOF and codomain of GOF, both I told. But one more important thing I will tell you, GOF will be defined only when range of f is the subset of domain of G. When range of f GOF is defined only when range of f is the subset of domain of G. You have to keep in the mind, range of f is B and domain of G is B. So range is the subset of domain or not? Yes, range is the subset of domain. Here in this case you can say range equals domain. So range is the improper subset of domain, we can say. Range of f is the improper subset of domain G. Or if you are taking fog will be defined when range of G is equal to is proper subset of domain of f. These two things you have to keep in the mind. When GOF is defined, GOF will be when range of f is equal to domain of G, and fog when range of G equals domain of f. So these two things you have to keep in the mind, then only this composition will be defined. Now I am going to take some questions from exercise. You can see here. Question number 3. Find GOF3, fog1, FOF0 if, second part I am taking, fx equals mod x plus 2, gx equals minus x square. So GOF, fog and FOF you have to find. So solution you see, fx equals mod x plus 2, gx equals minus x square, it is given. Now first of all, GOF x I am finding. First of all, GOF x. GOF x means g of fx. G of fx. Now you can see, g of fx means here you can put the value of fx. What is the value of fx? Mod x plus 2. So you can write g of mod x plus 2. Fx value you have put mod x plus 2. Now what is the meaning of g mod x plus 2? What is the meaning of this g mod x plus 2? It means that in the function gx, in place of x, you put mod x plus 2. So gx is minus x square. So in place of x, what do you have to put? Mod x plus 2. So that's why I have put minus same. In place of x, mod x plus 2. And here x square is there. So mod x plus 2 whole square will be there. Okay. Now you see, GOF 3 you have to find. So GOF x is minus bracket start mod x plus 2 whole square. So GOF 3 will be, in place of x you put 3. So GOF 3 equals minus bracket start mod 3 plus 2 whole square. So minus 5 square minus 25. Now in the same way we will find fog. Fog x means f of gx. Now value of gx you put. Value of gx is minus x square. Now in function fx, in place of x, minus x square you put. Fx is mod x plus 2. Now in place of x, minus x square you will put. So minus x square plus 2 you can see. Now fog 1. Fog 1 means in place of x, in fog x, in place of x, in fog x you put 1. So minus 1 square, fog x is mod minus x square plus 2. So mod minus 1 square plus 2. So minus mod minus 1 plus 2. Mod 1 is equal to 1. So that is the answer of fog 1. Next part you can see FOF x. FOF x means f of fx. F of fx. So fx value you put mod x plus 2. So f of mod x plus 2. Now again in the function f, in place of x you put x plus 2. So function x is mod x plus 2. Now in this function, in place of this x you have to put mod x plus 2. So that's why I have written mod x plus 2 plus 2. Okay. Now you see FOF 0. FOF 0 means in the function FOF x, in place of x you put 0. So FOF 0 means mod 0 plus 2 plus 2. You can see FOF x is mod x plus 2 plus 2. So in place of x I have put 0. So mod 0 plus 2 plus 2. So mod 0 plus 2 is mod 2 and mod 2 is 2. So mod 2 plus 2 is coming. Mod 2 plus 2 is coming. So mod 4 means 4. So this is the answer of FOF 0. Now you can see question number 5. Question number 5, if ux equals 4x minus 5, ux equals 4x minus 5, vx equals x square, fx equals 1 upon x, find u of f of vx. u of f of vx. So first of all, vx you put. What is vx? Vx is x square. So u of f of x square, you can see here. Only in place of vx I have put x square. Now this fx square is written. So in the function fx, in place of x you put x square. So function fx is 1 upon x, you can see. So in place of x, when you put x square, so it will become 1 upon x square. So value of fx square means 1 upon x square. Value of fx square means 1 upon x square. Now in the function ux, in place of x you have to put 1 upon x square. You can see ux is 4x minus 5. So in place of x you will put 1 upon x square. So it will become 4 into 1 upon x square minus 5. 4 into 1 upon x square minus 5, that is 4 upon x square minus 5. So this is the answer of second part. Third part I am taking f of u of vx. F of u of vx. First of all, vx value you put x square, you can see. Now in the function ux, you put in place of x, x square. In the function ux, in place of x, you put x square. So function ux was 4x minus 5. So in place of x, I have put x square. So 4x square minus 5, it will become. So this is the value of ux square. 4x square minus 5 is the value of ux square. Now it has become f 4x square minus 5. So in the function fx, in place of x, you put 4x square minus 5. So function fx was 1 upon x. So in place of x, what you have to put? 4x square minus 5. So it will become 1 upon 4x square minus 5. So this is the answer of third part. Here composition of three functions was there. U, V and F. Composition of three functions. U, V and F. So you have seen how to combine, how to make the composition of three functions. Now you can see question number 8. If fx equals 1 minus x upon 1 plus x, then f of f cos theta is equal to, what will be the value of f cos 2 theta? 4 options are given in this questions. I did not write 4 options because in front of you I will explain this question, and whatever correct option is there, that we will get as answer. That option we will get as answer. You can see fx equals 1 minus x upon 1 plus x, it is given. First of all, I will find the value of f cos 2 theta. F cos 2 theta. You can see f cos 2 theta means in place of x you put 2 theta in function fx. So 1 minus cos 2 theta upon 1 plus cos 2 theta. 1 minus cos 2 theta value is 2 sin square theta. By trigonometry you know. 1 plus cos theta value is 2 cos square theta. 2 is cancelled with 2. So sin square theta upon cos square theta, tan square theta. Now f of f cos 2 theta, what will be its value? F of f cos 2 theta. So f cos 2 theta value you have found tan square. So I have put here tan square theta. In place of f cos 2 theta, I have put tan square theta. Now in the function fx, in place of x, you have to put tan square theta. So I have put here 1 minus, it was 1 minus x upon 1 plus x. So in place of x, you have to put tan square theta. 1 minus tan square theta upon 1 plus tan square theta. Now you remember the formula 1 minus tan square theta upon 1 plus tan square theta. It is the identity of cos 2 theta. Formula of cos 2 theta. Cos 2 theta equals minus tan square 1 minus tan square theta upon 1 plus tan square theta. So this is the final answer. Now question number 11, you can see if fx equals sin square x and composite function g of fx equals mod sin x, then find function gx is equal to, what is the value of function gx? Important question. You can see this question how to solve. Fx equals sin square x is given, g of fx is mod sin x. By the definition of modulus function, you know very well mod x equals under root x square. So in the same way, mod g of fx is mod sin x. So mod sin x means under root sin square x. Under root sin square x. Again I am telling to you, mod x means under root x square. It is the definition of modulus function. So in the same way, mod sin x is under root sin square x. Mod sin x is under root sin square x. So g of fx is under root sin square x. Now fx value can be put here in LHS. So g fx value is sin square x. So g of sin square x is under root sin square x. Now you can see here g sin square x is written, here under root sin square x is written. This sin square x you can replace by x. When you replace this sin square x by x, both the sides, then you can have gx equals mod x, under root x. Gx equals under root x. So this is the function gx. So like this you can find, if composition is given and one function is given, so other function can be found. Now 14th question you can see, if fx equals 25 minus x to the power 4 whole power 1 upon 4, x is given from 0 to greater than 0 to less than root 5, then prove that f of f 1 upon 2 is equal to 2 to the power minus 1. 2 to the power minus 1 means 1 upon 2. 2 to the power minus 1 means 1 upon 2. So f of f1 upon 2 is equal to 1 upon 2 you have to prove. You can see the solution. Fx is given 25 minus x to the power 4 whole power 1 upon 4. So first of all, f of fx you have to find. Fx value you can put, fx value is 25 minus x to the power 4 whole power 1 upon 4. I have put. So now you are having f of 25 minus x to the power 4 whole power 1 upon 4. Now in the function fx, in place of x, you have to put 25 minus x to the power 4 whole power 1 upon 4. So you can see this step. Fx was 25 minus, in place of x I have put 25 minus x to the power 4 whole power 1 upon 4 in place of x only, but it was given x to the power 4. So in place of x I am putting 25 minus x to the power 4 whole power 1 upon 4, and outside power, this outside power 4 is same, you can see here, this is outside power 4, and outside the bracket 1 power is given 1 upon 4. So this is 1 upon 4 power. You can see this power. So now 4 is cancelled with 4. You can see 4 is cancelled with 4. So you are having 25 minus 25 plus x to the power 4. 25 is cancelled with 25, x to the power 4 and whole power 1 upon 4. So final answer you are getting x after simplifying. So x means f of fx is x, f of fx you are getting x. Now in place of x you put 1 upon 2 both the sides. So f of f1 upon 2 is equal to 1 upon 2, 2 to the power minus 1. So these were the questions from exercise 2b. I tried to take all difficult questions here, and I took difficult questions. I explained the difficult questions of exercise 2b. Remaining questions you can do. If you have any problem in solving the remaining questions, then you can ask, I will clear your doubts. Now one important information I will give you, students. Actually this week is the last week of online teaching before summer vacations. This week is the last week of online teaching before summer vacations. After this week your summer vacations will start. So this is the time to give you holidays homework. This is the time to give you holidays homework. So what you have to do in holidays homework, you see here, I have written here class 12th maths holidays homework. You can see solution of all ISC questions given at the end of each chapter from chapters 1 to 4 to 8. From chapters 1 to 4 to 8 means after each chapter one exercise is given for self assessment. This is the name of the exercise, for self assessment. In this exercise, questions from ISC ISC questions are given, means questions which came in board exam in previous years, questions which came in board exams in previous years. So these questions are given in exercise for self assessment. So from chapter number 1 to 4, 5, 6, 7, 8, from each chapter these exercise you have to do, these questions you have to do, ISC questions. And if you have any doubt in solving these questions also, so you can ask. And if you have any doubt in holidays homework, then today I am telling to you this holidays homework till Saturday your class will be there, means your online teaching of maths will be there. I will teach you till Saturday on this I will make the videos. So it means that if you have any doubt in holidays homework, you can ask, I will clear your doubts. So thank you and have a nice day.